Good morning to one and all. Today in this live lecture we shall discuss the linear equations of the first order. That means in the partial differential equation we shall discuss how to form the solution of the linear differential equation of the first order, that is the integral of the linear equation of the first order we shall discuss today. Now actually this is the first unit and we are here, that is linear equation of the first order. Then we shall discuss the Pfaffian's equation and compatibility of system. Now what is meant by the linear of equation of the first order? We shall discuss this first. We shall write the definition of the linear equation of first order. See this, a quasi-linear partial differential equation of a first order is of the form capital P into P plus capital Q into Q, which is equals to R, where P, Q, R are the functions of x, y, z. P, Q, R. In this case, P, Q, R are the functions of x, y, z, such that such a partial differential equation is known as Lagrange's equation. Such a partial differential equation is known as a Lagrange's equation. So we consider example xy into P plus yz into Q, which is equals to xz. What is the notation? Can you tell me, students, what is the notation for P and what is the notation for Q? Here P and Q are the particular notations which are used to the partial differential equation of z with respect to x and partial differential equation with respect to y. So these are the first order linear partial differential equation. Now we shall move towards the theorem. Lagrange's method of solving linear partial differential equation. See this, Lagrange's method for solving a linear partial differential equation. Okay, सारिका पराळे आहे का? जे अशात ॲब्सेंट विद्यार्थी जे राहिलेत असे एक 10 ते 15 दिवस झाला ॲब्सेंट असलेल्या विद्यार्थ्याचे तू नाव पाठव, कारण परीक्षा फॉर्म भरायचा आहे, त्यांना परीक्षा फॉर्म भरू नाही द्यायचा. जे सतत ॲब्सेंट राहायला लागलेत ना त्यांना परीक्षा फॉर्म नाही भरू द्यायचा. चला रे सांगा. आणि जे आन्सर उत्तर देतात ना, जे उत्तर देतात त्यांचीच प्रेझेंटी घ्यायचं. विनाकारण प्रेझेंटी टाकून काही जण विद्यार्थी जातात. क्वेश्चन विचारल्यानंतर जे सतत आन्सर देतात त्यांचीच प्रेझेंटी घे. बाकीच्यांना कुठल्याही परिस्थितीमध्ये आपण एक्झामला बसू देणार नाही. सो Lagrange's method of solving linear partial differential equation, the general solution of the Quasi-linear. आणि दुसरं महत्त्वाचं म्हणजे सर्वांनी ज्यांना तिथं सेमिनार घ्यायला सांगितले त्या दिवशी प्रत्येकाने सेमिनार घ्यायचं. तुम्ही सेमिनारला पीडीई घ्या किंवा ओडीई घ्या, काही अडचण नाही, पण परफेक्ट पद्धतीनं तयारी करून घ्यायचं. आजपासून सर्वांनी सेमिनार पण दिले पाहिजेत आणि भागवत सूचना स्ट्रिक्टली द्यायचं, सर्वांना व्यवस्थित सूचना देऊन कंप्लीट काम करून घ्यायचं, प्रत्येकाकडून करून घ्यायचं, लूज सोडायचं नाही. ओके, नाव द जनरल सोल्युशन ऑफ द Quasi-linear इक्वेशन इज P of x, y, z, capital P of x, y, z into P plus Q of x, y, z into Q, which is equals to R of x, y, z, where P, Q, R are the continuous differentiable function of x, y and z, is f of u, v is equals to 0, where capital F is arbitrary differentiable function of u and v, and u of x, y, z, which is equals to 0, and v of x, y, which is equals to C1. 0 nahi hai, sorry, we shall write this as a C1, and v of x, y, z, which is equals to C2, are the two independent solutions of this system. We have to prove u and v are two independent solutions of this system. We have to prove this. Okay, this is the Lagrange's theorem, Lagrange's method of solving the linear partial differential equation. This is the statement, and now we have to discuss the proof of this theorem. This is the statement. Okay, now we shall move towards the proof. Given Cauchy-linear differential equation is p of x comma y comma z into p plus q of x comma y comma z into q, which is equals to r of x comma y comma z. So we can write in the short capital P into P plus capital Q into Q, which is equals to r. The solution of this equation 1 is in the form f of, we have to prove the solution of this equation in the form that is f of u comma v is equals to 0, where f is the arbitrary differentiable functions of u and v, such that again u is a function of x comma y comma z, which is equals to c1, v is a function of x comma y comma z, which is equals to c2. Now we have to prove this result according to this condition. So now taking the partial derivative of u and v, we have to take the partial derivative of u and partial derivative of v, then we will get, see this, dou u by dou x into dx. See this, u is a function of x, so we have to differentiate this partially with respect to x, y, z. Then we can write dou u by dou x into dx plus dou u by dou y into dy plus dou u by dou z into dz, which is equals to 0. Constant c1 चा derivative 0. Similarly, we can write dou u by dou x into dx plus dou v by dou y into dy plus dou v by dou z into dz. Now suppose this is equation number 4 and equation number 5. We know that according to the consistency of equation, consistency condition of the equation, we can represent its solution in the form of a determinant. In the form of determinant, how we can write dx divided by mod of, now see this, we have to calculate. आता हा dou u यालाच आपण असं लिहू शकतो ना, ux into dx plus u suffix y, dou u by dou y means u suffix y into dou dy plus u suffix z into dz, which is equals to 0. And this also we can write in this way. How we can write? Dou v by dou x means vx into dx plus vy into dy plus vz into dz, which is equals to 0. So now by the consistency of equation, we can remove this u. Now we have to find out the denominator of x. So we can write dx divided by, now the coefficients of dy and dz. So uy, we can write this uy. uz, we can write uz. Plus, second row मध्ये vy plus vz. Okay. In this way, we can write dx divided by uy, uz, vy, vz. Similarly, we can write dy. Now we can write dy for आता dy ला लिहू शकतो आपण. dy ला कसं लिहिता येईल पहा. If we take the dy here, then reduce this dy. So coefficient of dy, how we can write? uz, okay, this is uz, and ux, पुन्हा काय? vz and vx, vz and vx. Similarly, we can write for z, साठी लिहिता येईल z. So we can write z, then reduce this ux, uy. So we can write ux, uy, vx, vy, vx, vy. In this way, we can write, we can reduce this equation in the form dx divided by uy, uz, vy, vz, dy divided by uz, vx, Vz Vx, and dz by Ux Vy Vx Vy. So by taking the cross multiplication, we can solve this determinant of order 2 by 2. Dx divided by Ux Vz minus Vz Uy. So we can write dy divided by Uz Vx minus Ux Vz. So dz divided by Ux Vy minus Vy into Vz. Okay. So according to this, we can write, now this is the, so now check this, we can write this Ux Vy Vx Uy. आता आपण याला लिहू शकतो, याला कॉन्फरन्स द्या, ठीक आहे. Now we can convert this in the form of, see here, dou u by dou x into dx plus dou v by dou y, dou of u comma v divided by dou of y comma x, okay, which is equals to d by dx, sorry, it's dy. 1 minute. Here we have to consider y, and here we have to consider dz. So we can write this in the form of, okay, we can write in this form Ux Uy Yz हा जो असतो ना, that is in the form. So we can write this in the form काय म्हणतात रेला. सो कसं लिहिलं पहा, Ux Vz minus Uz Vy. So dou Uv divided by dou Yz. Similarly, we can write Uz into Vx minus Ux into Vz. So dy divided by dou u comma v dou z comma dou x. Z आणि x आहे पहा, z आणि x. Third, dou z divided by dou u comma ux comma vy minus uy comma vx, that is dou z divided by dou u comma v, dou z divided by dou u comma v upon dou x comma y. This is called the Jacobi notation. This is the Jacobi's notation, and according to the Jacobi's notation, we can write here capital P, capital Q, capital R in the notation form. P, which is equals to dou u by dou x into P म्हणजे dou u by dou x into dou y comma z. Suppose we consider these notations here in this form. So PQR, we can write this notation dou u by dou u comma v divided by dou yz. Q is equals to dou u comma v dou zx. R is equals to dou u y divided by dou xy. And we have seen in the theorem first, actually we have seen in the theorem first, the solution of a differential equation f of u comma v which is equals to 0 is in the form that this solution is in the form, we can write capital P into small p plus capital Q into small q, which is equals to R, and which leads to the differential equation capital P into P plus capital Q into Q plus which is equals to R. That means we can write in this way dou u by dou x. So we can write in this way, हे z आहे पहा, z comma y, okay. So we can write in this way here dou u comma v divided by dou z comma y according to Jacobi's solution, small p plus dou u comma v divided by dou z comma x into q which is equals to dou u comma v divided by dou x comma y, which is equals to r. So this is the solution. In this way we can represent this is the linear differential solution of the linear differential equation, and this shows that f of u comma v is equals to 0, where u is u of x comma y comma z, which is equals to c1, and v of x comma y comma z, which is equals to c2, are two independent solutions of the linear differential equation. This and hence proved. अशा पद्धतीने हा प्रूफ कंप्लीट होतो. सो यू मस्ट नो दिस. इथं पहा, हे चेंज करा, इथं y आहे, इथं z आहे, आणि इथं z कॉमा y आहे, z कॉमा y. Okay, so we can write this p dx divided by p, which is equals to dy divided by q, which is equals to dy divided by z, is of a solution of we can represent the solution in the form of, so differential equation. So there are two independent solutions of the system of differential equations, which is represented by the auxiliary form dx divided by p, dy divided by q, dz divided by r, is the solution of p of p plus q of q, which is equals to r of x comma y comma z, and hence proved. Okay, हा थेरम अशा पद्धतीने प्रूव्ह करायचा. म्हणजे हे सोल्युशन आहे दाखवायचे. वी हॅव टू प्रूव्ह f of u comma v is equals to 0, which is the solution of the differential equation p of p in a bracket x comma y comma z into p, q plus q of x comma y comma z into q, which is equals to r. But we can write in the differential equation solution in this way. Okay, चला ठीक है. Now we shall move towards the find the general solution of following first order linear differential equation. आता याच्यावरचे बेस्ड आपण प्रॉब्लेम सॉल्व करू. प्रॉब्लेम्स खूप इझी आहेत. फर्स्ट प्रॉब्लेम xp, we have to solve these linear differential equation. First is xp x into p plus y into q, which is equals to 0, or this is also denoted by x into dou z by dou x plus y into dou z by dou y, which is equals to z, and we have to solve this partial differential equation, which is in the form of a linear and first order. So given differential equation is xp plus yq, which is equals to z. The Lagrange's auxiliary equation for 1, याचं Lagrange's auxiliary equation कसं लिहिणार पहा. जनरल फॉर्म मध्ये कसं असतो, आपण थेरम आत्ताच पाहिलाय. इफ द इक्वेशन इज p into p plus q into q, which is equals to r, where capital P, capital Q, capital R the functions of x, then we can write its auxiliary equation is dx divided by x, dy divided by y, dx divided by p, dy divided by q, which is equals to dz divided by r. Means dx divided by coefficient of p. So we have to write dx divided by coefficient of p means this. और यालाच असं आपण लिहू शकतो, capital P into small p plus capital Q into small q, which is equals to r. So it will be p. हा काय असेल, capital P. हा काय असेल, q चा coefficient capital Q, आणि हा काय असेल, r. So in the Lagrange's auxiliary equation we can write this equation dx divided by p, p means small x, which is equals to dy divided by q, q means small y, and which is equals to dz divided by r, r means small z. So dz divided by r, r means small z. In this way we can write the auxiliary equation. समजते का auxiliary equation कसं लिहायचं ते? हा काय म्हणतात तुम्ही? फर्स्ट इक्वेशन का एक मिनिट मी पाहतो रचना भागवत काय म्हणतात. कुठं फर्स्ट मध्ये यू वाय यू झेड यू वाय यू झेड फर्स्ट टर्मला का यू वाय व्ही झेड बरोबर आहे ना. यू वाय व्ही झेड इज इट इज ओके. अच्छा अच्छा ओके ओके इथं यू वाय ओके राईट यू वाय व्ही झेड आणि यू झेड व्ही एक्स एस एस ओके राईट आहे भागवत करेक्ट आहे. you have to solve this determinant. So uy vz minus vy uz or uz vy. Okay, in this way you can solve this determinant of order same. Okay, so it will be the equation of y comma z. We can write in the form of Jacobi's notation. Okay, right. Now we shall move towards this. Now replace this dx divided by p means x, which is equals to dy divided by q means y, dz divided by z. Taking first two members of the equation. Now we shall take these first two members. So dx upon x, which is equals to dy upon y. Now this is the variable separation form. So we can take the integration by taking the integration. So dx upon x, which is equals to dy upon y. Therefore integration of this dx upon x का integration होता है log x, which is equals to dy upon y का integration होता है log y, which is equals to, suppose integration constant is log c, suppose c1. Now we can take on left side, that is log x minus log, this is x log x minus log y. We can write log of x divided by y, which is equals to log c, and we can compare by taking the antilog, or by comparing we can write x divided by y is equals to c1. This is the first term, that is u of x comma y comma z. Similarly we can take last two members of the equation 2. आता पहा इक्वेशन 2 चे आपण फर्स्ट 2 घेतले होते. आता लास्ट 2 means dy upon y and dz upon z. So dy upon y is equals to dz upon z by integrating log y, which is equals to log z plus log c2. So log y minus log z is equals to log c2. Log of y divided by z is equals to log c2. So y divided by z is equals to c2. So the general integral is, we can write f of x divided by y comma y divided by z, which is equals to 0. You know that, we know that according to the theorem, Lagrange's theorem, f of u comma v is the solution of the given differential equation. So f of u means actually this term x divided by y c2 c1, and v means in this way. So we can write this as a 4, that is from, so f of u comma v is the solution according to the Lagrange's theorem. So f of x divided by y comma y divided by z, where f is the arbitrary function and which is the general integral, or which is the general solution of the given first order partial differential equation. हे समजलं का रे तुम्हाला? परत एकदा पहा, समजलं ना? हे खूप सिंपल आहे. फर्स्ट ऑफ ऑल वी हैव टू राइट इन द ऑक्सिलरी फॉर्म, then we have to take first and third, first and second, or first and third, you can take any term, and you have to solve this equation, then we get the solution of this form. Okay, now we shall move towards the second problem. What is that second problem? See this, yz into p plus xz into q, which is equals to xy. Now the given differential equation is yz into p plus xz into q, which is equals to xy. Suppose this is 1. Now Lagrange's auxiliary equation of equation 1, we can write dx upon yz, which is equals to dy upon xz, which is equals to dz upon xy. Now we have proved that the solution f of u comma v is the solution of this differential equation. That means alternatively we can show that solution of this differential equation. Now taking the first two members of this equation, now we shall consider first and second member of these two equations. Then what will happen? So dx divided by yz, which is equals to dy divided by xz. So we can cancel zz from the denominator. So dy upon x, which is equals to dx upon y, which is equals to dy upon x. But these are not, this is not an equation which is a variable separation form. So by taking the cross multiplication, we shall make it as a variable separation form. So x into dx, which is equals to y into dy, this is the variable separation form of the equation. So we can take the integration. आता integration घ्या. So by integrating integration of x dx, which is equals to y dy, so we can write x square divided by 2, which is equals to y square divided by 2 plus c. So x square is equals to y square plus 2c. So we can write x square minus y square, which is equals to 2c. We can consider 2c as a c1. As a c1, there is no problem. So we will write x square minus y square, which is equals to c1, that is u of x comma y comma z, which is equals to c1. You can taking the second member of equation 2. आता या इक्वेशन 2 चे दुसरे दोन मेंबर घ्या. dy upon xz, which is equals to dz upon xy, dy upon xz, which is equals to dz upon xy. So we can cancel x, dy upon z, which is equals to dz upon x. Now separate this by taking the cross multiplication, y dy, which is equals to x dz. Now by integrating, y च integration y square by 2, z च integration z square divided by 2, which is equals to c, multiplying by 2. So y square, which is equals to z square plus 2 into capital C. आता इथं पहा, इथं आपण small c वापरला होता. Consider this is a small c. Now here we have to consider this as a capital C. Okay, so 2c and 2 into capital C as we considered as a C2. So we will get the another equation of the form v of x comma y comma z, which is equals to C2. And according to the Lagrange's theorem of solution of the first order linear partial differential equation is f of u comma v, which is equals to 0. So we can write the general solution f of u, x square minus y square comma y square minus z square, which is equals to 0. Okay, so this is the complete second problem. Now we shall move towards the third problem. X into y square minus z square into p minus y into z square plus x square into q plus which is equals to x square plus y square into z. Okay, so now we have to show that the solution of this differential equation. Okay, so the given differential equation is, suppose as it is equation number 1, we can write in the auxiliary equation form of equation 1, auxiliary equations of this equation, dx divided by x into y square minus z square, which is equals to equations dy divided by minus y into z square plus x square, which is equals to dz upon z in a bracket x square plus y square. Okay, we can write these different equations. So its auxiliary equations are, so now we can write this. आता काय केलं पहा, इक्वेशन सॉल्व करण्यासाठी, सोल्यूशन घेण्यासाठी बाकीच्या टर्म एक्स स्क्वेअर वाय स्क्वेअर झेड स्क्वेअर आहेत. इथं एक्स होता म्हणून एक्स न डिवाइड मल्टिप्लाय केलं फर्स्ट रेशोला, डिवाइडिंग बाय मल्टिप्लाइंग बाय एक्स फॉर फर्स्ट रेशो, डिवाइडिंग and multiplying by equation y to the second ratio. Similarly, we can divide and multiply by z to the third ratio. So we will get this equation x dx divided by x square in a bracket y square minus z square, y divided by minus y square into x square plus z square, plus z divided by z square in a bracket x square plus y square. Now by the equal ratio test, तुम्हाला माहित आहे पहा, by the equal ratio test we can add, we can subtract that term. So we can write according to the property, आपल्याला तुम्हाला माहित असेल पहा, suppose a divided by b which is equals to c divided by d which is equals to e divided by f. We can write in this way a plus c plus e divided by b plus d plus f, which is equals to, we can write e divided by f. or we can write c divided by d, whatever may be. So in this way we can write. So by the equal ratio test, x dx, by adding numerator numerator, denominator denominator, and put this again last term as it is. So now solve this. आता परत ह्याला solve करा. That will be x dx plus y dy plus z dz. Then we get all the term of denominator will be 0. आता actually this is a denominator which goes to 0, but meaning of this is not equals to इन्फिनिटी. याचा मिनिंग इन्फिनिटी होत नाही, लक्षात ठेवा. याचा मिनिंग इन्फिनिटी होत नाही ऑक्झिलरी इक्वेशन मध्ये. सो दिस रेशो विल बी 0. सो हे कॅन्सल होतं पहा, एक्स स्क्वेअर वाय स्क्वेअर, एक्स स्क्वेअर वाय स्क्वेअर, झेड स्क्वेअर एक्स स्क्वेअर, झेड स्क्वेअर एक्स स्क्वेअर. इन दिस वे वी कॅन राईट x dx plus y dy plus z dy upon 0, which is equals to dz upon x into x square plus y square, z into x square plus y square. Actually, suppose it will be the lambda, the ratio of this term will be the lambda, then we can take this into this term. So x dx plus y dy plus z dz, which is equals to, these are the equal ratio. See this, these are the equal ratio. We can write that equal ratio, value of that equal ratio lambda. We can suppose lambda. So in this way, if we suppose this lambda, then we can write, transfer this 0 in the multiplication, that is lambda into 0. This implies that x dx plus y dy plus z dz, which is equals to 0. Now by integrating, this is the variable separation form. So by integrating, integration of x dx is x square by 2. Similarly, integration of y dy is y square divided by 2. Integration of z dz is z square divided by 2. Multiplying by 2, so it will be x square plus y square plus z square is equals to 2c. We consider this 2c as a c1. So we can write this as a x square plus y square plus z square is equals to c1, which is in the form of u of x comma y comma z, which is equals to c1. हे आपण कशासाठी लिहिलो? We have to compare this with the theorem. आता याला आपल्याला theorem सोबत कंपेअर करायचे म्हणून असं लिहितोय. ओके. सिमिलरली आता पहा, this is the first solution, that is u of x comma y comma z, which is equals to c1. This is the first independent solution. This is the first independent solution, which is in the form of u of x comma y comma z, which is equals to c1. Now we have to find out the second independent solution, v. Again we shall move towards the equation second. Now we can write this. We have to write this dx divided by x in a bracket y square minus z square. We can write in this way, dx divided by x upon y square minus z square. Similarly, we can write dy upon minus y divided by z square plus x square. In this way, we can write from equation second, from auxiliary equation, we can write this second form. Also from second, dx upon x y square minus divided by y square minus z square minus dy upon y, which is divided by z square plus x square, which is equals to dz upon z, which is equals to dz. Put this third term as it is. There is no any problem for the third term. So we can write dx upon x minus dy upon y. By the equal ratio test, adding numerator and as like a divided by b, which is equals to c divided by d, which is equals to e divided by s. Then by equal ratio test, we can write ac divided by bd, which is equals to e divided by x, and which is the same value that is having a lambda. There is no any problem. So by the equal ratio test, we can write addition of the numerator of first two terms in the denominator, addition of the denominator of the first two terms. So y square, so we can write z square, x square. So we can write plus z square minus z square will be get cancelled. So y square plus z square. So dx upon x, which is equals to minus dy upon y, which is equals to dz upon z, that is y square plus z square. So 1 minute, काय झालं रे, काय राहतं इथं, झेड झेड कॅन्सल झाला ना, एक्स स्क्वेअर प्लस वाय स्क्वेअर राहतं. So plus z square minus z square will be get cancelled. So remaining term is x square plus y square on the left side, and right side is already we have given x square plus y square. So this x square and this x square y square we can remove. Then remaining terms are dx divided by x minus dy divided by y, which is equals to dz divided by z. Again by taking the integration, because this is a variable separation form, so we can write, okay, बरोबर आहे संभाजी जाधव, very good, log x minus log y, which is equals to log z plus log c. So log of x divided by y, which is equals to log of z into c. So log log cancel, x divided by y, which is equals to z into c. So we can write x divided by y z is equals to c, और reciprocal गया, y z divided by x, which is equals to 1 upon c, and we can write 1 upon c as a c2, since 1 upon c is a c2. So yz upon x is equals to c2. Hence the general solution is, this is v of x comma y comma z. This is v of x comma y comma z. So we can write this general solution. Okay. Now we shall discuss the next problem. Z into xp minus yq, which is equals to y square minus x square. So given differential equation is z into xp minus yq, which is equals to y square minus z square. Now we can write same, multiply by z. Then we have to write the auxiliary equation of the first. So dx divided by xz, which is equals to dy divided by minus yz, which is equals to dz divided by y square minus x square. Again we have to take first two members, first and second member here, and by using a first two member we can cancel zz. So it will be the, we can write integration. So we will write x y, which is equals to suppose c1. Now we shall take the second two members of this equation 2, same process. These are the very simple solutions, same two process, dy divided by minus y into z, which is equals to dz divided by y square minus x square. So ठीक आहे, so we can write this in the form. आता काय केलेला, मल्टिप्लिकेशनच्या फॉर्म मध्ये लिहिला. अगेन वी शॅल डिस्कस दिस. याला x न मल्टिप्लाय करा, याला y न मल्टिप्लाय करा. So we get this x divided by x square into z, which is equals to y into dy divided by y square into z, which is equals to z divided by y square minus z, means from 2. इथं गरज नाही, लास्ट टू मेंबर घ्यायची गरज नाही, सर्वच घ्यावं लागतील. सो वी शॅल राईट दिस. सो by using the equal ratio test, we can write x dx plus y dy is equals to x square minus y square into z, which is equals to dz divided by y square minus x square. Now you can write it as a minus in a bracket x square minus y square and cancel with this x square minus y square. Okay, so I have written here directly, this is from 2. Okay, so this x square minus y square and right side चा x square minus y square cancel होतो. इथं z आहे पहा, इथं कुठून आणला. ओके, तो x square minus y square x square minus y square होतो. हा z आहे तो राइट साइड ला ट्रांसफर करा. So x dx plus y dy minus z. Now this z is transferred on right side. So minus z dz. That means we can write this sides by integrating x integration x square by 2, y integration y square divided by 2, and minus z integration z square divided by 2, which is equals to suppose c, capital C, and multiplying by 2, then we can write x square plus y square plus z square, which is equals to 2c, and consider 2c as a capital C, 2c as a c2, which is the another form, second independent solution. समजलं का रे हे? This is also second independent solution, and hence we can find the solution. Okay, चलो next we shall move towards the next problem, third problem. y square z divided by x into p, small p, plus xz into q, which is equals to y square. So we can write this as a given differential equation is, so y square z divided by x into p, x z into q, which is equals to y square. Suppose this is 1. The auxiliary equation is काय तर auxiliary equation dx divided by y square z upon x plus which is equals to dy divided by xz, which is equals to काय तर dz upon y square. Suppose this is equation number 2. Taking first two terms, taking first two members of 2, then what will happen? So dx divided by y square z upon x, which is equals to dy upon xz. Z will be get cancelled. We can cancel this z, so we can write x dx divided by y square, which is equals to dy. So we can write x dx, which is equals to y square dy. Now this is the variable separation form. This is the variable separation form. By taking integration, then what will happen? Then we can write this as integration of x dx, which is equals to integration of y square dy. So we can write x is equals to y cube by 3. बरोबर आहे का? पहा बरे, x is equals to y cube by 3. Which is equals to plus c x square. एक मिनिट हा, काहीतरी राहिलं पहा, है ना? हा ओके, इथं पहा हे झड झड कॅन्सल होतं, झड झड dy divided by x राहिला, dy divided by x here, so it will be x square. So x cube by 3. इथं पहा राइट साइडला झड झड कॅन्सल होतो. नाउ दिस झड and this z will be get cancelled by multiplying z. Then what will happen? So take the reciprocal of this dx divided by y square and dy divided by x as it is. Okay, so we can write x cube, which is equals to y cube plus 3c, that is we can write x cube minus y cube, which is equals to c1. This is the first independent solution. Student, this is the first independent solution. Now we shall find the second independent solution. आता आपल्याला काय करायचंय? सेकंड इंडिपेंडंट सोल्यूशन घ्यायचंय. आता सेकंड इंडिपेंडंट सोल्यूशन घेत असताना लास्ट टू टर्म घ्या, फर्स्ट अँड द लास्ट फ्रॅक्शन. आता आपण काय करू? फर्स्ट आणि लास्ट फ्रॅक्शन घेऊ. लास्ट सेकंड आणि थर्ड घेतलं तर कॅन्सल नाही होणार. एक्स जेड आहे तिथं वाय आहे, म्हणून आपण काय करू? फर्स्ट आणि लास्ट टर्म घेऊ. टेकिंग first and last term of 2. So what is that? First dx divided by y square upon x, which is equals to the last term is dz upon y square. Is it okay? आता इथं काय होतं पहा, see this y square we can take a cancel, so we can write x dx divided by z, which is equals to dz. So x dx is equals to z dz. by integrating x चं इंटिग्रेशन x स्क्वेअर बाय 2, z चं इंटिग्रेशन z स्क्वेअर बाय 2 किंवा 2 न मल्टिप्लाय करा, मल्टिप्लाइंग बाय 2, 2 न मल्टिप्लाय करा आणि मग इथं घ्या. सो इट विल बी x स्क्वेअर minus z square is equals to c1 c2. Suppose this is equation number 4. Hence the required solution is, मी डायरेक्ट घेतलं पहा c2. c2 is the constant term. We can take c2 as a 2 times of c. There is no problem. So we can write f of u, first independent solution is x cube minus y cube, second independent solution is x square minus z square, okay, which is equals to c. And hence proof. समजलं ना हे? तर अशा पद्धतीने याचं प्रूफ होतं. मी होमवर्कला तुम्हाला 1-2 प्रॉब्लेम देतो, तुम्ही ते सॉल्व करा. होमवर्क so you can solve this. yz into p plus xz into q, which is equals to x plus y. Second, 1 plus y into p plus 1 plus x into q, which is equals to z. Okay, you can take this, right? Third, y square into p minus xy into q, which is equals to x in a bracket z minus 2y. Okay, now solve these problems. These are for the homework. अशा पद्धतीने हे सोल्यूशन होतं. So today we have discussed one theorem, Lagrange's theorem, which is used to find the general solution of the first order linear partial differential equation. But first of all, we have to convert this into the auxiliary equation. We have to convert this given differential equation into the auxiliary, and then we can find the solution, which is in the form of f of u comma v is equals to 0, where u and v are the independent solution. Okay, now we shall stop.